In January of this year, in Australia, a Chinese electric SUV that almost nobody outside the industry could name sold 415 units in a single month. That figure put it fourth on the national electric vehicle chart. It also put it ahead of the Tesla Model Y, a car that had spent the previous year utterly dominating that market with more than 22,000 sales. The car is called the Geely EX5, and the reason it is winning has almost nothing to do with the bodywork, the screen, or the badge. It is buried under the bonnet, sealed inside a single block of aluminium, roughly the size of a carry-on suitcase. Geely calls it the 11-in-1. Inside that one casing sit 11 separate systems that every other manufacturer on Earth still bolts down individually and connects with meters of orange high-voltage cable. This is the story of what happens when somebody decides that all of that wiring is simply a design failure. And before we take it apart, if you are new to Camber and Curve, this is what we do here. We open up the engineering that the brochures skip over. Hit subscribe now, because the next 10 minutes are going to change how you look at every electric car on your street. To understand what has been removed, you first have to understand what a conventional electric car actually looks like underneath. The motor sits in one location. The reduction gear sits beside it. The inverter is its own unit. The onboard charger is another. The DC to DC converter, which steps high voltage down to run the headlights and the wipers, is another again. The battery management systems, one for the main pack, a second for the 12-volt auxiliary battery, live somewhere else entirely. So does the power distribution unit, the motor control unit, the vehicle control unit, and the thermal management hardware with its own network of hoses threaded across the chassis. That is 11 distinct systems, each with its own housing, its own mounting points, its own connectors, and its own run of cable. Geely's engineers took all 11 and fused them into one sealed aluminium block, not stacked in a shared box, integrated, sharing housings, sharing cooling, sharing control logic. The engine bay of the EX5 does not look like a car engine bay. It looks like a computer. Now, you may have seen a figure of 91% attached to this motor. That number is wrong, and it matters that you know why. The verified figure Geely publishes is 90.04%. And critically, that is peak efficiency, measured under homologation conditions at the motor's optimal operating point. It is not what the car achieves on a wet Tuesday on the M6 with the heater running. Every manufacturer quotes peak. Tesla quotes peak. Porsche quotes peak. So the honest way to read 90.04% is this. At its best, less than 10% of the energy leaving the battery is lost to heat and mechanical friction before it reaches the road. That is genuinely a threshold figure. Crossing 90% is the line that has historically separated ordinary production motors from racing hardware. But it is a peak figure, and anyone who rounds it up to 91 and drops the word peak is selling you something. Here is the part that the specification sheets never explain, and it is the entire commercial point of the exercise. High voltage cable is expensive, not because of the insulation, but because of the copper inside it. And copper is one of the single costliest materials in a modern electric car. Every meter of it you delete is money that comes straight off the build cost. But the cable itself is only half of it. Every connector at the end of every cable is a manufacturing step, a tolerance, a torque specification, a quality control checkpoint, and, critically, a potential point of failure. A connector that works loose over 8 years of vibration and thermal cycling is one of the most common faults in high-voltage systems. Fuse 11 components into one casing, and you do not just save copper. You delete dozens of connectors, dozens of assembly operations, and dozens of things that can eventually corrode, loosen, or arc the savings compound. And then there is the space. Strip the labyrinth of cabling out of the engine bay, and the designers can push the bulkhead forward, which buys legroom in the cabin and open up a usable storage well at the front where the electronics used to live. same exterior dimensions, more car inside. But there is no free lunch in engineering, and the 11-in-1 buys its advantages by creating one very serious problem. When you seal 11 high-power electronic systems inside a single aluminium casing, you have built yourself a heat trap. Inverters run hot. Control electronics degrade quickly when they run hot, and the motor's own lubricating oil will break down chemically if the inverter sitting next to it keeps cooking it. Geely's answer is a thermal system they call Magic Cube. Oil cooling running through a bi-directional 360-degree circuit that wraps the stator and the power modules simultaneously, rather than cooling them separately. According to Geely's own certified figures, this increases the active heat dissipation surface by 35% compared with a conventional electric motor. That is the claim. And here is the honest caveat. This entire architecture is only as reliable as that cooling circuit and the software that governs it. If the control system misjudges coolant flow, or if the circuit degrades, internal hotspots will age the electronics far faster than the manufacturer intends. Geely talks about an 800,000-kilometer service life for this drivetrain. Treat that as a manufacturer's ambition rather than a certified result, because that is what it currently is. The 11-in-1 does not work alone. It is paired with Geely's short blade battery, lithium iron phosphate cells in a shortened blade format, which reduces the pack's internal resistance. Lower internal resistance means less energy wasted as heat inside the pack itself before the electricity even reaches the drive unit. Lithium iron phosphate is the interesting choice here. It is less energy dense than the nickel-based chemistries in most European and American electric cars, which is why the headline range figures are respectable rather than spectacular. But it is cheaper, considerably more thermally stable, and it tolerates being charged to 100% daily without the degradation penalty that nickel chemistries suffer. For a family car that spends its life doing school runs and commutes, that is arguably the correct engineering trade, not a compromise. Geely has chosen durability and cost over a bigger number in the brochure. This is where the story stops being a Chinese technology story and becomes a British one. Geely Auto launched formally in the United Kingdom on the 23rd of October, 2025, and the EX5 was the car it launched with. Prices start at £31,990 on the road for the entry-level SE. The warranty is 8 years or 125,000 miles, covering both the car and the battery, among the longest offered by anybody currently selling cars in Britain. At launch, there were 25 franchise dealers open, with a target of 100 nationwide by the end of this year. And Geely is not the unknown quantity the badge suggests. This is the group that owns Volvo, Polestar, Lotus, Smart, and the London electric vehicle company that builds the black cabs. Geely-owned brands already account for a meaningful slice of every electrified car sold in Britain. The technology has been under British roads for years. This is simply the first time the parent company has put its own name on the bonnet. Australia is where the theory met the scoreboard. Geely returned to the Australian market in early 2025 after more than a decade away, and it returned with the X5. By January of this year, that car was selling 415 units a month and sitting fourth on the national electric vehicle table, ahead of the Model Y. To be precise about what that does and does not mean, Tesla was having a poor month, and 1 month is not a trend. The Model Y sold more than 22,000 units across the previous year and remains the benchmark. But the direction of travel is unambiguous, and the infrastructure tells the same story. Geely's Australian dealer network went from 20 locations at launch to 49. You do not build 49 dealerships for a car that is not selling. The 11-in-1 is not a concept on an auto show stand in Shanghai. It is a product that ordinary Australians are financing over 4 years. So here is the awkward question, and it is the one that ought to matter most to anybody actually considering buying one of these. What happens when a sealed block fails? Traditional architecture is inefficient, heavy, and expensive to build, but it is modular. If your onboard charger dies in year 6, an independent garage removes the onboard charger and fits a new one. That is a bounded, quotable repair. Now consider a unit where the onboard charger shares a housing, a cooling circuit, and a control board with 10 other systems. Is that a component-level repair? Or is it a replacement of the entire drive unit? Geely has not published a serviceability breakdown. And until independent technicians have worked on high-mileage examples, nobody outside the company genuinely knows the answer. This is not a reason to dismiss the technology. Tesla faced precisely the same criticism over its integrated castings and largely absorbed it. But it is the single largest unknown in the ownership case. It will not surface for another 5 or 6 years, and it will be settled by insurance write-off statistics rather than by press releases. There is one market where this entire conversation is purely academic. In the United States, tariff policy on Chinese-built vehicles has made the EX5 commercially impossible. An American buyer cannot walk into a showroom and see this technology, cannot test drive it, and cannot compare it against a Model Y on price. A British buyer can do all three for £32,000. So can an Australian, a New Zealander, and a growing list of European buyers. Whatever your view on the trade policy, and there are serious arguments on both sides of it, the practical outcome is that the two largest English-speaking car markets in the world are now having completely different conversations about what an electric family car costs and what it should contain. Strip away the marketing and the 11-in-1 is a statement about vertical integration. Geely can do this because it controls the chips, the cell chemistry, the software, and the motor design in-house. A manufacturer that buys its inverter from one supplier, its onboard charger from another, and its battery management system from a third, cannot fuse those components into a shared housing block because it does not own the intellectual property in any of them. That is not a temporary problem that can be solved with a bigger research budget. It is a structural consequence of the supplier relationships that European and Japanese manufacturers spent 40 years building and optimizing for the combustion era. Those relationships were an enormous competitive advantage. In an electric drivetrain, they have quietly become an anchor. So, 11 systems, one sealed block, 90.04% at peak, already on British and Australian driveways, and structurally difficult for the established manufacturers to copy. Is integration on this scale the correct direction for the electric car? Cheaper to build? More efficient? Better packaged? Or have we quietly traded away the ability to repair our own vehicles for a few percentage points of efficiency and a slightly larger boot? Both positions are defensible, and I suspect the answer depends entirely on whether you intend to keep the car for 3 years or for 15. Tell me which side you land on in the comments. I read them, and the best argument usually ends up pinned. If this breakdown was useful, a like genuinely helps. And if you have not subscribed yet, now is the moment. This channel goes this deep every single week, and the next one takes apart the short blade battery that feeds this thing. You will not want to miss it.